Welcome back. This is Mrs. Rewrite with Algebra 1 Honors. Today's lesson is 7-1, Factors and Greatest Common Factor. Use the prime factorization of each coefficient and the powers of each variable. So we're trying to find the greatest common factor of 8y squared and 4y to the fourth. So 8y squared is 2 times 4 times y times y. Right? 8y squared. And then down here, 4y to the fourth is 2. Oh, you know what I should have done? I don't like how they have it set up. Okay, so I should have wrote it like this, sorry. 2 times 2 times 2 is 8, right? Because we're getting down to prime numbers. I shouldn't have put a 4 there. Sorry, guys. I just made your papers messy. And 4 would be 2 times 2. And y to the fourth is y, 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 and y. 4 y's, right? Circle the common factors above. So a 2 and a 2, a 2 and a 2, a y and a y, a y and a y. Find the product of the common factors. So there's a 2, a y, and a y. So 4y squared. Right? 2 times 2 is 4, y squared. So the GCF of 8y squared and 4y to the fourth is 4y squared. It's the highest number they have in common. So think about this as, I like to just think of it separately. So between 8 and 4, what's the largest number that goes into both? 4. How many y's do they both have? What's the highest number of y's they have in common? 2 of them. And I'm done. They just like to draw it out and make it a little bit more confusing than it needs to be. Use another method. Write each monomial as the prime factorization of each coefficient and the variable raised to its power. So 8 is 2 times 2 times 2. 4 is 2 times 2 times y to the fourth. Find the product of the common factors of the coefficients and the variable that is raised to the lowest power. (4y squared). How does this product compare to the GCF you found in step A? They are the same. Another way to find the GCF of two monomials is the same variable is to multiply the blank of the coefficients times the variable that is raised to the blank power, so to the lower power, and it's the GCF. Two whole numbers are relatively prime if the only common factor they have is 1. Give an example of two monomials that each have a coefficient and a variable that could be described as relatively prime. Explain your thinking. So if you had 8y squared and 5z to the third, the only common factor of the coefficients is 1, and neither variable is common or is a common factor of both monomials. So they're different letters. So there's nothing in common you can pull out. And between 8 and 5, there's nothing that goes into both of them that can be pulled out, right? How can you apply the method you described in step C to find the GCF of 6x squared y to the fifth and 9x cubed y to the third? So what number can I pull out of both of these? Doesn't 3 go into both of these? Okay, so 3 and what? How many x's can I pull out? And how many y's? right? They have at least 3 in common. Because this one has 3 of them, this one has 5 of them, so they have 3 in common. This has 2 and this has 3. So that's like the highest number that I can pull out of them. This is your GCF. Make sense? How many variables are in the GCF of that? Explain. Find the GCF. So what can you pull out of here? You can pull out a 2, right? 4 and 6 have 2 in common. And you can pull out a squared. Can you pull out any b's? This one has 1, that one has 0, so no. So 2a squared is your GCF. How many variables are in the GCF of that and that you can pull out? Like, so there's only, the only variable, a is a factor in both of them, right? A is the only one that you can pull out of both. All right, so find the GCF of that, and that. So what's the highest number that they have in common? What can you pull out of all of them? You can pull out a 6 out of 6 and 12, but not out of 9. What do all 3 of them have in common? A 3, right? So the coefficients are 9, 6, and 12. So the GCF of the coefficients is 3. Is a common factor of all of the monomials? So a squared, a, and b. No, because there's not an a in all of them. Is b a common factor of all the monomials? You can take out, there's b squared, b to the third, and a b. One b can get out of all of them, right? So yes, b to the first, right? So write b in the lowest power, b. What is the product of the GCF of the coefficients of any common variables raised to their lowest powers? 3b, right? You can pull out a 3 and you can pull out a b. The GCF of 9a squared, b squared, and 6ab cubed and 12b is 3b. That's the highest number that you can pull out of all 3 of those. How could you change the monomials in the example so that they are relatively prime? Give an example. So I could change the coefficients so they have no common factors. I could remove b cubed from 6ab cubed so that b isn't a common factor. So 2a squared b squared, 3a, and 5b are relatively prime. Suppose you were asked to find the GCF of 4 or more monomials. How would your method compare to the method used in the example? It'd be the same. The expression 3 times x plus 5 squared can be factored as 3 times x plus 5 times x plus 5. The coefficients 3 in the binomial x plus 5 are factors of the expression. X and 5 are not factors of the expression. This is important when finding the GCF of the expressions involving binomials. Find the GCF of 6 times x minus 3 cubed and 8 times x minus 2 to the 4th. The coefficients are, what are the coefficients, guys? 6 and 8, right? So the GCF of the coefficients is going to be, what goes into 6 and 8? 2. Is the binomial x minus 3 a common factor of both? Yeah, right? It's in both. Write x minus 2 with the lowest power to the third, right? What is the product of the GCF and the coefficients and the common binomial raised to the lowest power? So 2 times x minus 2 to the third. The GCF of 6 times x minus 2 to the third and 8 minus x to the fourth is 2 times x minus 2 to the third. Suppose the expressions in the example had been 6 times x, 2x minus 4 to the third, and 8 times x minus 2 to the fourth. What additional steps would you need to do? You would need these to be the same. So in order to do that, I can pull out a 2, right? Can I pull out a 2 from here? Like reverse distributive property it? That would be 6 times 2 times x minus 2 to the third, right? And 8 times x minus 2 to the fourth. So that's 12 x minus 2 to the third and 8 x minus 2 to the fourth. Right? There's one thing I didn't do. I was supposed to factor out a 2 how many times? Because I'm taking the 2 out how many times? 3 times. So it's really 2 to the third. And 2 times 2 is 4 times 2 is 8. And 6 times 8 is 48. Because I'm pulling out the 2 on something 3 times, because I'm pulling it out from the x minus 2 times the x minus 2 times the x minus 2, right? I'm pulling, because this is the same thing as 6 times 2x minus 4 times 2x minus 4 times 2x minus 4. So I'm pulling, this is the same thing as 2 times x minus 2, 2 times x minus 2, 2 times x minus 2, and it's all of this times 6. So it's really 6 times 2 times 2 times 2 times x minus 2 cubed. Does that make sense, guys? That I'm pulling it out not once, not twice, but 3 times, because I'm pulling it out of the 2x minus 4 3 times. And 2 to the third is 8. So it's 8 times 6, which is 48. Do you guys see what I did? So you have this and 8 times x minus 2 to the fourth. Are we okay with that? What is the GCF of that chunk and that chunk? Explain your work. Is this the same thing I just did? Okay, so if we have 48 times x minus 2 to the third and 8 times x minus 2 to the fourth, what's the highest number in common between 8 and 48? 8 and 48. What's the highest number between 8 and 48? And the highest number 8. Don't they both have an 8 in common? 6 times 8 is 48. 8 times 1 is 48. And then the x minus 2, how many do they have in common? 3 or 4? What's the most that they have in common? What's the lowest exponent? 3. They have 3 of them in common. So 8 times x minus 2 cubed is the lowest binomial common to both expressions. How would the GCF be different in the example if the expression 5 times x minus 2 squared had also been included? So if I had 48 times x minus 2 to the third, 8 times x minus 2 to the fourth, and 5 times x minus 2 squared. 48, 8, and 5, do they have anything in common in terms of numbers? No, right? The coefficients don't have anything in common. The x minus 2, what's the largest in common of the x minus 2s? The third, the fourth, or the second? How many do they have in common? What's like the highest number that they have in common? Do you guys understand what I'm saying by what's the highest number of x minus 2s that they have in common? They have 2 of them, 4 of them, and 3 of them. What's the highest amount they have in common? 2 of them. Because this one has 2, this one has 4, so they have 2 in common. And this one has 3 of them. So all of them have 2 of them in common that can be taken out, right? So this is their GCF. There's nothing in terms of 48, 8, and 5 that are in common other than 1. So there's no whole numbers you can pull out of all 3. You can reduce them by. Find the GCF of each pair of monomials. So in terms of the whole numbers, right, your coefficients, 3 and 9, what's the highest number they have in common? 3. What's the most e's they have in common? E squared. 4 and 3, anything in common? No. F to the what? 4th. 7 and 8. No. M squared and no m's. No. P and P squared. P. 2 and 5. No. A to the 3rd versus A to the 4th. A to the 3rd. B to the 6th versus B squared. B squared. 5 and 6. No. H cubed, there's no h's. K cubed, no k's. So nothing. So if there's nothing that I can pull out, it's really just 1, right? Which is like nothing. So we'll just call it 1, even though it's like, yeah, the greatest common factor, 1. 1 goes into everything, right? 12 and 9, 3. X to the 5th and X to the 7th. Y to the 5th, Y to the 5th. Y to the what? 5th. X to the 5th, X to the 4th, X to the 3rd. What do we got? X to the 3rd. Y cubed, Y to the 4th, Y to the 5th. Y to the 3rd, or cubed. 6, 4, and 8. 6, 4, and 8, what do they have in common? 2. S to the what? 1st. T to the what? 1st. No, this one only has 1. So you have 1, 4, or 2. So it has to be 1. It's the lowest one, because that's what they all have in common. All right, so let's try 9. 10, 20, 15. 5. C to the what? Nothing, because the middle term doesn't have a C. D to the nothing, because the last term doesn't have a D. And they all don't have an E. So it's just 5. Right? Try number 10 and 11 with your table partner. Ten, 3a cubed b squared. 11, nothing, so 1. Try 12. They don't all have a T, they don't all have a V. W to the 4th. Try 13. This is W to the 4th. Oh, wait, no, there's a squared. You're right, because it's 4, 2, 4, 5, so it's squared. Good job. Thank you for being alert. I missed that one. Two and 5, nothing. You guys get y minus 3 to the 4th? Yeah. Try 14. Three times x plus 4 squared? Try 17. I think 17 is supposed to be a typo. As it's written, there's nothing. But if this was an S, if you just change the second one to an S, then it would be S plus 5 squared. No. S plus 5 squared. $18, 12, 4, and 9. Nothing, right? But you'd have a W minus 1. 6, 16, and 8. What is 6, 16, and 8? The highest number that goes into all of those. 2. Z plus 3 to the third. Try 20. Add h minus 5 squared. So your homework on this is going to be the workbook page 375 and 376. Right? 375 and 376. And I'm going to make this on page 375 evens. 376 all. Is everyone clear on that? On 375 is just the evens. So that's 2 through 28 even. 376 is 1 through 8 all. Is everyone clear on that? Okay. I hope you guys enjoyed this lesson on 7-1. Please like and subscribe and have a fantastic day.